In the most extreme frozen regions of the planet, where temperatures can plummet to minus 72 degrees Celsius and the cold acts as a silent predator, human survival seems impossible. Yet communities such as the Yakut and Evenki peoples have persisted for centuries in precisely these conditions. Their endurance is not solely the result of human willpower or ingenuity. A critical factor in their ability to inhabit these ice-bound lands lies in the presence and exploitation of 10 remarkable animal species that rank among the most cold-resistant creatures on Earth. These animals do not merely survive the relentless cold, they thrive in it, and in doing so, they have become the foundation of human life in such environments. These 10 species supply the essential resources without which permanent human settlement in the deepest cold would be untenable. Their meat, fat, blood, hides, fur, bones, sinew, and even milk have historically provided the calories, protein, vitamins, waterproof clothing, insulation, tools, and shelter materials that enabled people to withstand winters that last 8 to 9 months and routinely plunge far below minus 50 degrees Celsius. Without these animals, the caloric density required to maintain body heat, the raw materials for layered clothing, and the nutrient profile needed to prevent scurvy, anemia, and starvation would be unattainable in a landscape where no plants can grow and conventional agriculture is impossible due to permafrost. The relationship is symbiotic in the most literal sense. Humans hunt, herd, and harvest these animals, while the very existence of these cold-adapted species has made long-term human occupation of the region feasible. The Yakut and Evenki did not arrive in Siberia with pre-existing technologies perfectly suited to the cold. They adapted by closely observing and utilizing the animals that had already mastered the environment. Reindeer provided milk, meat, hides for clothing and tents, antlers for tools, sinew for thread, and even transportation. Polar bears and seals offered fat so energy-dense that a single kill could sustain a family for weeks. Arctic foxes and hares supplied fur trim for parkas and boots. Musk oxen and walrus hides furnished durable tent coverings and boat skins. Even the smallest creatures, lemmings hunted by foxes and owls, indirectly supported the food chain that kept larger prey abundant. The following examination details each of these 10 species, focusing on the precise mechanisms of their cold resistance, their reproductive strategies, feeding ecology, and behavioral adaptations. More importantly, it reveals how each animal directly contributed to human survival in the frozen north, turning an apparently lethal environment into a homeland. 1. Reindeer, Rangifer tarandus, the cornerstone of Arctic human life. Few animals have been as intimately linked to human survival in extreme cold as the reindeer. Capable of routinely withstanding air temperatures of minus 50 degrees Celsius and lower with wind chill, reindeer possess a double-layered coat. A dense underwool traps body heat, while long, hollow guard hairs repel water and snow. Their nasal passages contain a countercurrent heat exchange system that warms inhaled air before it reaches the lungs, preventing freezing of delicate respiratory tissues. Broad concave hooves act as snowshoes, distributing weight to prevent sinking and serve as paddles when swimming across rivers and lakes. Reproduction is synchronized with seasonal migration. After an 8-month gestation, females give birth to a single calf in late spring, typically during the herd's journey to traditional calving grounds. Newborns stand within minutes and can run within hours, an essential adaptation to evade wolves and other predators. The timing ensures calves are born when fresh vegetation is emerging, allowing rapid growth before the next winter. The diet consists primarily of lichen, reindeer moss, mosses, and frozen grasses excavated from beneath snow using hooves and antlers. In winter, lichen provides carbohydrates despite its low nutritional value. Specialized rumen bacteria efficiently break down cellulose. During summer, fresh grasses and shrubs allow rapid fat accumulation for the coming cold season. Reindeer undertake some of the longest terrestrial migrations on Earth, up to 5,000 kilometers annually, following seasonal food availability and avoiding deep snow. Both sexes grow antlers, unique among deer, which are used for digging through snow and defense. In severe storms, they form tight groups to share body heat and reduce wind exposure. For indigenous peoples of Siberia, reindeer have been the single most important animal for survival. They provide milk, rich in fat and protein, meat, blood, used for sausages and soups, hides for clothing and tent coverings, the fur is exceptionally warm, sinew for thread, antlers for tools, and most crucially, living transportation. A single reindeer can carry 100 to 150 kilograms and pull sleds loaded with supplies across hundreds of kilometers of snow. Without domesticated reindeer herds, long-distance travel, trade, and the transport of food stores during winter would have been impossible. The Evenki and other groups have practiced semi-nomadic reindeer herding for centuries, moving with the herds to follow lichen pastures and avoid overgrazing. Reindeer are not merely livestock, they are mobile survival systems. Their ability to find lichen beneath deep snow by pawing and digging taught people how to locate scarce food resources. When reindeer herds suffered from starvation during poor lichen years, human communities faced famine, illustrating the direct dependence of human survival on the animal's own struggle against the cold. 2. Polar bear, the provider of high-energy fat. Polar bears tolerate air temperatures of -50 degrees Celsius and wind chills that can feel like -70 degrees Celsius or lower. Their black skin absorbs scarce sunlight, while a dense layer of translucent hollow guard hairs traps insulating air and reflects light for camouflage on sea ice. Beneath lies up to 11 centimeters of blubber, serving as both thermal shield and energy reserve, enabling them to swim for hours in near-freezing water without hypothermia. Females excavate maternity dens in deep snowdrifts during late autumn, often on stable coastal slopes. These snow caves maintain internal temperatures around -20 degrees Celsius, despite blizzards outside. After an 8-month gestation, including delayed implantation, 1 or 2 cubs, each weighing less than 1 kilogram, are born in midwinter. The mother fasts for up to 8 months, nursing her young with milk containing approximately 30 to 35% fat, the richest among bears, to rapidly build insulating blubber in the cubs. The family emerges in spring when the cubs are ready to face the ice. Diet centers on high-calorie marine mammals. Polar bears are obligate carnivores, primarily hunting ringed and bearded seals at breathing holes or on ice floes. They consume the energy-dense blubber first, up to 8,000 kilocalories per kilogram, leaving lean meat for scavengers. When prey is scarce, they feed on whale carcasses, seabirds, eggs, or even kelp. Their sense of smell detects seals beneath thick ice from distances of 30 kilometers or more. Polar bears are largely solitary and nomadic, with adult males roaming territories up to 100,000 square kilometers and swimming hundreds of kilometers between ice floes. To conserve energy in extreme cold, they enter a state known as walking hibernation, reducing metabolic rate without full torpor. When resting, they curl into a ball, covering the sparsely furred nose with a paw. For northern indigenous peoples, polar bears have historically been a critical source of fat, the single most important macronutrient in a cold environment where energy expenditure is extremely high. A single adult bear can yield 200 to 300 kilograms of blubber, providing tens of thousands of calories per kilogram. The fat was rendered into oil for lamps, consumed raw or cooked, and used to waterproof clothing. The hide furnished durable sleeping mats and tent coverings, while sinew from the back served as exceptionally strong thread. Polar bear hunting was dangerous and ritually significant. Successful hunts were celebrated and the meat shared communally. Even today, polar bear fat remains a prized source of concentrated energy during prolonged winter travel and hunting expeditions. The bear's ability to fast for months while nursing cubs mirrored the human need to ration food stores through long winters, reinforcing the cultural respect for these animals as fellow survivors of scarcity. 3. Musk ox, the woolly fortress. Musk oxen withstand minus 60 degrees Celsius thanks to their Kiviut undercoat, the finest natural fiber known, warmer and lighter than cashmere, combined with long guard hairs that reach the ground, forming a protective skirt against wind and snow. Females produce one calf per year after an 8 to 9 month gestation, typically in late spring. Calving occurs in traditional herd areas where adults can protect the young. The diet includes dry grasses, sedges, willows, and lichens foraged from beneath snow. In winter, they paw through drifts to reach vegetation, conserving energy by limiting unnecessary movement.
Musk oxen are highly social and defensive. Herds of 10 to 100 individuals huddle together during blizzards to share body heat. When threatened by wolves or bears, adults form a tight circle with horns facing outward and vulnerable calves protected in the center, a formation that has helped the species survive near extinction in the past. During the rut, males emit a strong musk odor from glands to deter rivals. For indigenous Arctic peoples, musk oxen provided one of the warmest natural fibers known, Kiviut. The soft underwool was collected during spring shedding and spun into exceptionally warm garments that weigh almost nothing, yet insulate better than most modern synthetics. The long guard hairs were used for ropes and tent guy lines. Meat and fat supplied critical calories and vitamins, while horns were fashioned into tools and utensils. Muskox hunting required coordinated group effort. The defensive circle formation made individual animals difficult to kill, so hunters targeted isolated individuals or waited for opportunities when animals were separated from the herd. The animal's presence in the tundra ecosystem ensured a reliable source of high-quality protein and insulation materials even in the leanest winters. The Kiviut garments allowed humans to move more effectively in cold winds, reducing energy expenditure and enabling longer hunting trips. 4. Arctic fox, the versatile scavenger and fur provider. The Arctic fox withstands air temperatures down to minus 70 degrees Celsius, thanks to its compact body and unmatched fur density. Weighing only 3 to 8 kilograms, it possesses the thickest fur-to-body size ratio among mammals, with an undercoat so dense it feels like velvet. Short muzzle, small ears, and short legs minimize surface area for heat loss, while fur-covered paws function as natural snowshoes, preventing sinking and frostbite. Breeding occurs in early spring, with females producing litters of 5 to 8 kits, occasionally up to 14 in years of abundant food, inside complex underground dens excavated into permafrost hillsides. These dens, often centuries old and expanded across generations, feature multiple escape tunnels. Kits are born blind and helpless in May or June and are nursed until they can hunt small prey. Both parents share duties. The male provisions food, while the female guards the den. The diet is highly opportunistic. In winter, Arctic foxes scavenge polar bear kills or trail them for scraps, but their primary prey is the lemming, small rodents that tunnel beneath snow. Using acute hearing, the fox leaps headfirst into drifts to capture prey. It also consumes birds, eggs, fish, carrion, and, in summer, berries. Seasonal coat color change provides perfect camouflage, pure white in winter against snow, brown or gray in summer on the tundra. When sleeping, the fox curls tightly into a ball, tucking its nose beneath its bushy tail to warm inhaled air. In winter, it becomes nomadic, traveling up to 4,000 kilometers in search of food, moving efficiently across snow to conserve energy. For indigenous Arctic peoples, the Arctic fox was a critical source of trim fur for parka hoods, boot linings, and mitten cuffs. The dense, silky fur provided exceptional insulation around the face and extremities, precisely where heat loss is greatest. Fox meat, though lean, was consumed when larger game was unavailable, and bones were used for the small tools and needles. Foxes also played an ecological role. By controlling lemming populations, they indirectly helped maintain the balance of the tundra food web, ensuring the availability of larger herbivores such as reindeer. 5. Walrus, the blubbery provider of coastal communities. Walruses inhabit waters at -2 degrees Celsius, protected by a 10-centimeter layers of blubber and thick, wrinkled skin that minimizes heat loss in freezing seas. Females give birth to one pup every 2 to 3 years on ice floes, typically in spring. They feed primarily on clams, snails, and other bottom dwellers using powerful suction to extract prey from sediment. Large aggregations of thousands haul out onto ice floes to rest and conserve heat through body contact. For coastal indigenous groups, walrus blubber was one of the highest calorie foods available, extremely energy-dense and rich in vitamin D and essential fatty acids. The hide provided exceptionally tough leather for boat coverings, umiak and kayak skins, boot soles and heavy-duty bags. Tusks were carved into tools, harpoon heads, and ornaments. Walrus hunting was a communal activity requiring multiple hunters in boats or on ice. The meat was shared widely throughout the village. The animal's presence near the coast provided a reliable source of fat and hide, even when inland hunting was impossible due to deep snow or poor reindeer migration. 6. Arctic wolf. The coordinated hunters of the north. Arctic wolves tolerate -50 degrees Celsius with thick, double-layered white fur for camouflage and insulation, along with short ears and muzzle to reduce heat loss. Only the alpha pair typically breeds, producing 4 to 6 pups annually in dens dug into permafrost. The entire pack participates in raising the young, providing food and protection. Their primary prey is caribou, hunted cooperatively using endurance running and strategic positioning. They also consume Arctic hares, lemmings, and carrion. Pack structure ensures survival. Coordinated hunts increase success against large prey, and members curl tightly together when resting to conserve heat. Howling maintains contact across vast, windy landscapes. For indigenous hunters, wolves were both competitors and teachers. By observing pack hunting techniques, people refined their own cooperative hunting strategies. Wolf fur trim on parka hoods provided excellent insulation around the face, while wolf meat was eaten in times of scarcity. The presence of wolves also indicated the location of caribou herds. Hunters often followed wolf tracks to find prey. 7. Arctic hare. The swift sow jumper. Arctic hares endure -40 degrees Celsius to -50 degrees Celsius with thick fur and compact bodies. They change color seasonally, white in winter, gray-brown in summer, for camouflage. Females produce 2 to 3 litters per year, with 4 to 8 leverets per litter born in shallow ground depressions. They feed on woody twigs, bark, roots, and frozen vegetation as excavated from beneath snow. They dig snow burrows for shelter, huddle in groups for warmth, and can sprint at speeds up to 64 kilometers per hour on powerful hind legs that act like snowshoes. Arctic hair fur was used for trim on clothing and boot linings, providing lightweight insulation. The meat, although lean, was an important source of protein during winter when larger game was scarce. The hare's ability to thrive in deep snow demonstrated how small animals could survive conditions that larger herbivores struggled with, teaching people to exploit even marginal food sources. 8. Snowy owl. The daytime phantom hunter, snowy owls tolerate minus 50 degrees Celsius with dense plumage and fully feathered legs. They nest on the ground, laying 3 to 11 eggs depending on prey availability. Their diet consists mainly of lemmings and other small rodents, up to 1,600 per year in peak years. They hunt primarily during daylight hours, using silent flight over open tundra. Snowy owl feathers were occasionally used for arrow fletching and small decorative items. More importantly, the owl's population cycles closely followed lemming cycles, serving as a natural indicator of small mammal abundance. When snowy owls were abundant, lemming numbers were high, which in turn supported fox, wolf, and even human hunting success indirectly through the food chain. 9. Walrus, the blubbery provider of coastal communities. Walruses inhabit waters at minus 2 degrees Celsius, protected by a 10-centimeter layer of blubber and thick, wrinkled skin that minimizes heat loss in freezing seas. Females give birth to one pup every 2 to 3 years on ice floes, typically in spring. They feed primarily on clams, snails, and other bottom dwellers, using powerful suction to extract prey from sediment. Large aggregations of thousands haul out onto ice floes to rest and conserve heat through body contact. For coastal indigenous groups, walrus blubber was one of the highest calorie foods available, extremely energy-dense and rich in vitamin D and essential fatty acids. The hide provided exceptionally tough leather for boat coverings, umiak and kayak skins, boot soles, and heavy-duty bags. Tusks were carved into tools, harpoon heads, and ornaments. Walrus hunting was a communal activity requiring multiple hunters in boats or on ice. The meat was shared widely throughout the village. The animal's presence near the coast provided a reliable source of fat and hide even when inland hunting was impossible due to deep snow or poor reindeer migration. 10. Antarctic icefish. The transparent swimmers, without red blood. Antarctic icefish live in water below 0 degrees Celsius, their blood containing antifreeze glycoproteins and lacking hemoglobin, making them nearly transparent. They lay eggs on the seabed, with larvae hatching in spring. They feed on krill and small fish. Their clear bodies provide camouflage in the icy water column. Although primarily a southern hemisphere species, the icefish's antifreeze proteins have been studied extensively and inspired research into cryoprotectants that could one day benefit human medicine in extreme cold environments. The biological principle of non-freezing blood has parallels in some Arctic fish species that also produce antifreeze glycoproteins.